Hi, my name is Alex, and in this episode, we're going to talk about neural networks robotics. So, we're going to begin with what's a neural network? Let me tell you about this. Okay, so a neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. In this sense, neural networks refer to systems of neurons, either organic or artificial in nature. Neural networks can adapt to changing input so the network generates the best possible result without needing to redesign the output criteria. The concept of neural network, which has its roots in artificial intelligence, is swiftly gaining popularity in the development of training systems. Basics of neural networks in the world of finance, assistance in development of such process as time of series forecasting, algorithmic trading, security classification, credit risk modeling and constructing proprietary indicators and price derivatives. It is also used in the field that we're going to concern today as robotics. So, what can we say about neural networks with robotics? Well, we can begin with the saying that this automatically make robots more intelligent. The application of neural networks in robotics can go from kinematics is the study of the movement of multi-degree of freedom that forms the structure of robotic systems, and forward kinematics, the joint angles are the inputs and the outputs will be the coordinates of the end effectors. Inverse kinematics, the given inputs are the coordinates of the end effectors, and the outputs to calculate are the joint angles. Inverse kinematics is the difficult one because it's computationally intensive and has multiple solutions. Neural networks may be able to reduce the computational complexity. Robot dynamics is concerned with the relationship between the torques applied to the joint and the joint coordinates, velocity and accelerations. The non-linear mapping property of a neural network is important to deal with this kind of problems. Trajectory planning is the process of defining a desired path in joint or Cartesian space for joints or grippers. So there are a lot of applications for robotics, like from the most usual thing like Alexa or Echo Dot, Google Home. These can have neural networks in their system to interact with us. So we can give them answers and they will find in their neural network um, something to relation the what we are saying to them. So now we are going to go with the pros and the cons of the neural networks in robotics. Pros of using neural networks in robotics. First of one, a good method to deal with nonlinear systems and provide nonlinear models. Second, the ability of learning functions whose forms are difficult to derive using data recorded from a system or even learn online, then use what the previously learned to adapt to change happen to the system. Parallel processing, which results in a fast computing and processing. Multivariable system as it processes many inputs and outputs. Data fusion as it can operate both quantitative and qualitative data. Moving on with the cons, the probability of getting stuck in a local minimum is really a lot. Less accuracy, there's no known method to determine the number of nodes. Well, this is my presentation. So, in conclusion, we could talk about neural networks like the new future. As we know, this is going to be included in the AI, or more known as artificial intelligence, because robots are gaining a lot of importance. They are substituting a lot of works. I don't say it's correct, but it's something that it's going to happen. So if we can take all this new technology, all this new robotics in our lives and use it like a pro, we're going to gain more than we thought. So don't be afraid of the new technology, and let's keep moving. Thank you.